Okay, in section 3.4, we reviewed slope and slope-intercept form and point-slope form and the different ways that we learned these in Algebra 1. We're going to continue to review one more section, and we're going to write and graph equations of a line. So let's just jump right in. Again, this should be pretty much a review. So if I wanted to write the equation of this line, I need to find the slope and the y-intercept if I'm going to put this into slope-intercept form. Well, what's the easiest thing to find right away? Generally, it is your y-intercept, and in this case, your y-intercept is where the graph crosses the y-axis. The y-intercept is right there at 4 on the y-axis, or 0, 4 as a coordinate. So your y-intercept is positive 4. Next thing I need to do is I need to find my slope. So I'm going to have to count rise over run. First thing you want to always do, generally you want to count rise because that's the thing that goes in the numerator on the top of your formula. So my rise here is going to be down 1, 2, 3, 4, 5, 6. So I'm going to have a negative 6 slope. Then I'm going to count my run. Okay, my run is to the right, my over 1, 2, 3. So it's a positive 3 because I went to the right, so I went down 6 over 3. So negative 6 over 3, and that's basically what I'm going to write. Okay, so negative 6 over 3. Now you could have, and this is the example I'm showing you here, right here, you could have taken these ordered pairs and plugged them into the slope formula. However, I just find it easier when you're given a graph just to go ahead and count your slope. Count down 6 over 3. Then once I have my slope and my y-intercept, I can put it into point-slope form. I'm sorry, slope-intercept form, which is y equals mx plus b, and just simply plug in y equals negative 2 for the m, x plus b for my equation. Should be fairly simple. Any questions on that? Okay, if you have any questions, as always, write them down, bring them to me in tutoring. All right. What if I'm given a graph here? Okay, and here I have a cost in a month situation. Just out of review purposes, what is the independent variable there? That's right, the month is independent. Independent is always located on your x-axis. Independent, last year I taught independent to my Algebra 1 students. That's generally the thing that happens first. Okay, if that happens first, that's generally the independent thing. In most situations with time is almost always independent simply because you can't really stop time, and time generally happens before you can do anything else. Now there are a few rare instances where time is not independent, but we're not going to get into that right now. So if time is independent and month is independent, and then cost is always our cost is dependent, and dependent is always located on the y-axis. Okay. So that was just a quick review over independent and dependent. All right, again, if I want to find my slope, I need to count my rise. I'm going to go up 10, 20, 30, 40, and then my run is over 1. Okay. Now make sure you pay attention to the scale over here. I'm going up by 10s over here, but on my x-axis, I'm going up by 1. So make sure you pay close attention to that. So my slope is 40 because I have rise of 40 over 1. My slope is 40. Okay. What is my y-intercept? Well, that's where my graph touches or crosses the y-axis, and that's right here at 60, 70, 80, right? So now I have a slope and a y-intercept, so I can put that into slope-intercept form, and I end up with y equals 40x plus 80. But what does f of x there mean? Okay, that's right. That x is a. I'm sorry. This graph is a function of x. This is what we call function notation. This is still in y equals mx plus b form or slope-intercept form. It's just another way to write it using what we call function notation. We can do that because now we can find out other things. This is a $40 per month, so if I wanted to find out any particular month now, I can put that in there. So slope is a per month or a unit rate. And then, of course, our initial value, our y-intercept, is $80. That means we started at $80, and then each month we go up $40. But if I want to find out anything, I can plug it into the x values here, and if I want to find out what it would cost at 9 months, I can plug that in and solve the equation, or simplify, really. Okay, just another review question. What's our what's our domain? Okay, first, in order to know what our domain is, you have to know what domain deals with. The domain for a function is all of the x values in that function. So what are all our x values in this function? If you said all real numbers, you'd be incorrect only because our graph stops right here. Last year I taught my students to find a minimum and maximum if that was possible. In this case right here, there is a minimum. That minimum is 0. It does not go past 0 on our x-axis. So then it'd be x is greater than 0 because it's going to take up all my x values going this way. So I would put x is greater than 0 as my domain because the minimum was 0 and it's every number greater than 0. And it could be equal to 0 as well. So x is greater than or equal to 0. So what's the range for this then? Well, in this case, again, we're looking at the range being, we've got to know what the range is. Range for a function is all of the y values in that function. So again, I'll look for a minimum y value if possible. So I go to my y-axis. Does it stop going down my y-axis? Absolutely. Right here at 80, that's the lowest point on my y-axis it goes. It doesn't go any lower than that. So the way I would say that is that my range is y is greater than or equal to 80 because it includes 80, but then it's every number above 80. Okay. Again, just a review on domain and range. Okay, let's talk about standard form. This was a big killer at the very beginning of the year, especially for the sophomores that came into this class, because one, you probably didn't remember it if you were in my class, for some of you, and for those of you in other classes, it was a big deal whether it was taught or not taught. But standard form is another way that we can use to graph. It's not as functional as the y equals mx plus b, meaning I can't find a whole bunch of points as easily, but it is actually really easy to graph, and we didn't talk about this too much last year, but it's easy to graph with the standard form because all I have to use is the x and y intercepts. Okay, when I use the x and y intercepts, it's pretty simple because when I want to find the y-intercept, I know that my x value is 0. So basically all I have to do is take that away and now solve for y. And if I solve for y, I find out that 6 divided by -3, y equals -2. So I just found my y-intercept by simply removing the x part, because if I go back, if I put in 0 for x, 2 times 0 makes that, again, disappear. Okay, going back to my original equation again, if I want to find my x-intercept, I would do the same thing. I know I'd plug in 0 for y here, and a 0 for y here would be 3 times 0 is 0. That basically cancels, and that goes away. So now all I have to do is solve for x. And when I solve for x, I simply divide both sides by 2, and my x-intercept is 3. So now this standard form equation right here has given us an x-intercept and a y-intercept, which is 2 points on our graph. So the next thing we want to do is go ahead and plot those points, 3, 0, and 0, -2. Plot those points right here. All you need is 2 points to create a line. So once I have those 2 points, I just draw my line straight through. And that's how you graph using the standard form of a line. ax plus by equals c. Okay, you're going to need to know standard form for Algebra 2, so please don't let that slip your mind or memory. Okay? And again, if you have any questions, please feel free to write those down and come see me anytime in tutoring. And last but not least, let's go ahead and do a little scenario type question. This is a bank charges $1.50 for each use of a debit card. Another separate bank charges $10 a month for unlimited uses. How many times a month to make it the flat rate a better deal? So basically, if this is Bank A, the one that charges $1.50, and Bank B charges $10, how many uses do I have to use before Bank B becomes my better deal? Okay, so let's take a look. First thing I want to do is I want to label my my axes. Well, again, uses and costs. What depends on what? Well, what do I have to do before I get charged? The first thing I have to do is I have to use my debit card, and then I get charged. So what comes first? The uses comes first, and since the uses comes first, cost comes second. Uses is independent, and costs are dependent. Okay. So the next thing I want to do is I'm going to go ahead and plot the first one. The first, or the second bank, excuse me. That second bank says it just charges a flat rate of $10, okay? So no matter how many uses I have, it's $10. So that's just the function f of x is equal to 10, no matter what. So I'm going to put that 10 on their graphic, and I'm going to make my function. Now I want to graph the first one. Now I want to go ahead and graph that first one. A bank charges $1.50 for each use of the debit card, okay? So here's my function for that. It's g of x equals 1.5x. So I need to go ahead and plot that, okay? Well, it's not giving me an initial value, so I can start at 0. So I plot my point here, and then I'm basically going to go up 3, 1, 2, 3, over 2, 1, 2. And there's my point right there. So that's what that graph looks like right there. And so what we want to do now is, now that we have the two graphs, we're going to compare the two graphs together to find out what's the better deal. So basically, if I break this graph down, what you're going to see is this. Anything below, it looks like 10 uses. I'm sorry, not 10 uses, excuse me. Anything below, uses are down here, about 7 uses is going to be a better deal to get charged per use. At that 7 use mark, which is right about here, okay, at that 7 use mark, you're going to have the same fee. So if you use it 7 times, and that's every month, you use it 7 times, the debit card 7 times, it's not going to matter what company you go with, because you're basically going to be paying the same thing. But if you use it more than 7 times, then it's going to be cheaper to go ahead and pay the $10 flat rate, because when you pay $1.50 for more than 7, it goes up right here. Okay. Anything less than 7, it's better to use the $1.50 for each use. Anything more than 7, it's better to use the flat rate fee of $10. This is a really common real world type problem. A lot of people will use tables in order to solve this, but you have to sit there and put all this information in a table, and it takes a long time. If you can graph this, it makes it a lot easier. But companies do this all the time. I remember one year, this is before we had Netflix and all that, when there was actually video stores, and there was 2 big video companies, and one of them was Blockbuster and one of them was Hollywood Video. Well, Blockbuster came out, or Hollywood Video came out with this, hey, you can rent, you know, unlimited amount of videos for $20 a month. Well, then Blockbuster came out with something else and said, hey, you know what, we're not going to charge you $20 a month. We'll charge you $1 for every video rental plus a $10 fee for every month. And so then basically you're having 2 competing companies that, if you use one company for X amount of videos, then it's better, but then you would have to shift over to the other company if you bought more videos. So this is a pretty common deal. So you can actually apply this to the real world. And I know some of you guys right now are probably thinking, well, I don't have to worry about this. And you don't right now, but as you get older like me, you look for that best deal possible. This is when this really comes into play. All right, well, that's all of our review for that. And then a 3.6 section that we're coming up with tomorrow or the next video. Basically, you're going to be using the information that we use for review in order to prove that parallel lines are parallel, or perpendicular lines are perpendicular. All right, have a good evening. I will see you tomorrow.